Welcome back, folks, to the Rock the JVM channel. I'm Daniel, and in this video I'm going to show you an example of streaming analytics by integrating Apache Pulsar and Spark structured streaming. Now, this demonstration is done in Scala, although in theory you could also write Java if you're interested. So this video assumes comfort with the Scala language and with the basic Pulsar and Spark concepts that we have some videos of here at Rock the JVM channel, and also courses for Spark at Rock the JVM. As always, I recommend that you code with me in this video, and whenever you need to refresh your memory or you need to integrate Pulsar and Spark at your project or at your job, just refer back to this video or to the written form at the blog with the link in the description. And I recommend that you keep the blog post open next to you, because some of the code snippets that I'm going to show you in this video can be found in full on the article. I'm not going to type them from the beginning. So without further ado, let me show you the little project that I prepared for you. Now, unlike most of the other videos here on the Rock the JVM channel where I write code from scratch, here I already have some boilerplate code that I've already made and that you can also find on the blog post. So you can copy this to your own project after I've explained what each bit does. So I have here an empty project here in IntelliJ IDEA with the build.sbt declaring all the library dependencies that we're going to need in this video. So we need Spark Circe for parsing JSONs, and Pulsar and the Pulsar Spark connector that we're going to need for integrating Pulsar with Apache Spark structured streaming. So this entire build.sbt library definitions file can be found at the blog post. Now, we're going to simulate an integration between Apache Pulsar and Apache Spark, and we're going to push some events into Apache Pulsar. And I'm going to parse them from a CSV file that I have here with some randomized realistic data for an online store that I'm going to describe shortly. All right, so this events.csv file, you can also find it at the blog post. As for my Scala code, it contains 3 applications. I have here an application that I called Data Parser. It just parses this events CSV file and returns a list of a particular data structure that I've created here under an object that I called domain. So this object called domain has a case class definition for events of online store users. So this event contains a user ID, an event type, product ID and category ID, category code for the kind of product that this user interacted with, brand and price, describing the actual product, and the user session, which is a unique identifier for every user that we're going to use as a key to group several events in our online store. Now, in the case that these events cannot be correctly parsed, I also have an empty factory method in the companion object of this class to generate an empty event. And I also have another case class that I called analysis event, which contains fewer fields that we're going to combine and compute on the consumer end, which is implemented using Spark. So I have 2 case classes, one of which has a companion object, and I have a data parser here whose main API is just a function to load the events from a given file. With header, I defined a second parameter here, and all we need is to obtain a list of this event data types. So this is essentially what I've done here as boilerplate. You don't really need to care about how I implemented data parser. You can also take a look at the sketch implementation on the blog post. Now, I have here another object that I called constants, and this contains the topic of Apache Pulsar that we're going to use to push these events and then consume them on the Spark end. The events file path, this is the name of the file. The service URL and the admin URL, these are the connection links to Pulsar. The producer name is not really that important, and the thread pool size for running asynchronous message passing to Apache Pulsar. So this is essentially what I've done so far, and we're going to write all our code in 2 separate applications, one I called Event Analyzer, which is implemented using Spark structured streaming, and Event Producer, which is an application that pushes these events that I parsed from the file through Pulsar. Now, why is Pulsar so cool? I've created another video here on the Rock the JVM channel describing Pulsar and describing the features and the basic usage of Apache Pulsar, but in short, Pulsar in this example will be used for data collection. And there are a bunch of features of Apache Pulsar that make it specifically suitable for that. So Pulsar has a unified messaging and streaming architecture. That is, Pulsar can be used for data aggregation and collection as well as for backend logic in your distributed systems, much like Apache Kafka. Pulsar also has a tiered storage architecture, which makes it very suitable for long-term data retention even as data flows through Pulsar in real time. It's very easily horizontally scalable because you can distribute topics in between a bunch of machines, and as I've described elsewhere. It also offers low latency and high bandwidth streaming APIs so that you can process your data very, very quickly. And with Pulsar functions, which I think is a commercial feature of StreamNative, the company behind Apache Pulsar, you can also do some lightweight data analysis directly at the collection side, which is very powerful. So I'm going to start with the event producer based on Pulsar, and I'm going to type in directly in this main method of this object. So first of all, I'm going to fetch my events, assuming that I can fetch them from some other place in my data application, but here in this case I'm going to fetch them as a simple list. So I'm going to have data parser dot load events at the events file path, which is this one. So I'm going to use constants dot events file path, and I'm going to use with header equals true because the CSV file already has the header. So I already have my events. Now I want to push them to Apache Pulsar. So I'm going to create a Pulsar client, as I described in the Pulsar video that I've made here on the Rock the JVM channel. So I'm going to use Pulsar client that I need to import, and I need the service URL for Apache Pulsar. So I'm going to use constants.service URL. I'm actually going to import all the constants here. So I'm going to import constants everything, and I'm going to use the service URL. And I'm going to use a topic. So topic equals topic with a capital T, and I'm going to use the topic name, which is simply called events. So when we actually start the Pulsar Docker container, I'm going to create the events topic, and then we're going to start this event producer application. Cool. So I'm going to create a val called event producer as Pulsar client dot producer, and I'm going to use the type event here. So I'm going to import the domain, which defines the data type. So I'm going to use producer with event, and I need a producer config data structure to create this event producer correctly. So I'm going to have a producer config that I need to import. So the producer config will have to contain the topic that I've created earlier. I will give this a producer name. So producer name equals, and I'm going to fetch this constant over here, event-producer. The name is not really that important, but I've placed it in the constants. So I'm going to have sum with producer name, because this has to be an option. And then two more settings. I'm going to have enable batching as some true, and block queue if full, I'm also going to have some true. I describe these parameters in the Pulsar video. Now, this event producer needs to take an implicit to create the schema that Pulsar can understand for these data structures that we want to support, which is obviously custom. So I will add an import at the top. So import, and I'm going to import com esky Samuel, Pulsar 4s, Circe, everything. So Pulsar 4s is the Pulsar library for Scala, and Circe is a Circe integration inside this library itself. Now, this import needs to be also bundled with a macro-based Circe import to automatically generate encoders for case classes. So I'm going to import IO Circe generic auto, which should trigger this import and should eliminate this compiler error. Now, with this event producer in place, I can use it to asynchronously send each and every one of these events to Pulsar asynchronously. So I'm going to have events map. And for every event, I'm going to create a message that Pulsar can understand. In other words, I need to marshal an event for Pulsar into an envelope specific to Pulsar. So I'm going to have my message envelope as default producer message. So default producer message is a simple data structure, so I'm going to use its apply method. And default producer message has a type, which in my case, it's event. And I will pass an identifier, which is a sum containing the event.userid. Then the payload, which is the event itself. And the time of the event, which is a sum with event time, in all caps, event time containing event.eventTime. So this is a little bit of a boilerplate code, but I need to create this little envelope so that I can send it to Pulsar. So I can say event producer dot send async, and I'm going to pass this message envelope to Pulsar. Now, this implicit requirement is called async handler, and this is automatically generated for Pulsar if we have an execution context implicit in scope. So here in this event producer application, I'm going to define my implicit execution context. First of all, I'm going to define an executor as executors.new fixed thread pool, and I'm going to use my thread pool size configuration from my constants. So I'm going to have my thread pool size, and then I'm going to define an implicit val EC of type execution context as execution context from executor service, and I'm going to use this executor. And notice that as soon as I have this execution context, my implicit requirement disappeared. All right, so this async handler was created automatically by the compiler for me. Now, the act of sending an asynchronous envelope to Pulsar returns a future, which contains a message ID. So I'm going to keep that. And this message ID future, I'm going to onComplete that. So I'm going to have message ID future onComplete. And in case I get a success containing a message ID, I'm going to print something so that I can log. So I'm going to have print line, let's say, ACK received for message ID, and I'm going to inject ID here. And in case I get a failure with an exception, I'm going to print line failed to send message, reason is, and I'm going to inject X here. And finally, as a result of this map, I'm going to return the message ID future. So this whole expression is going to be a list of, for every event, I'm going to return a future. So I'm going to return a list of futures. So let's call this message ID futures. So this is going to be a list of future of type message ID. Now, message ID is a data structure from the Pulsar 4S library, and obviously the future I need to import. Now, finally, in main, I'm going to turn this list of futures into a future containing a list. So I'm going to use traverse. So I'm going to have future.sequence. This is a variant of traverse that turns these double nested types inside out. So I'm going to use future sequence, and I'm going to pass my message ID futures. And then I'm going to chain this giant future. So I'm going to say, and then, and in case I get success with whatever values, then I'm going to print line all messages sent successfully. And in case I get a failure with some exception, then I'm going to say print line a failure occurred. Check the logs for the stack trace. And I'm going to inject my little exception here. Cool, and then I'm going to chain that a little further with and then. And finally, in case I get anything, I'm going to simply close my event producer. So I'm going to have my event producer close. So this is it. This is a simple application based on Pulsar that fetches a list of events from some source in your application, in my case it's a simple file, and then asynchronously sending each to Pulsar. Now, what do these events mean? So if we look at the events.csv file, we have the date of the event and the event type, which are view, cart, and purchase. So cart means that a user added this particular product into their shopping cart, and purchase means that they've actually bought them from our online store. So naturally, we're mostly interested in the cart and purchase events. And because we're using Apache Pulsar, we would like to investigate in close to real time how the users are actually using our online store. And a common issue with online stores is that people have added many things in their shopping carts, but they don't actually purchase them. So we might be interested in analyzing the kind of sessions that have many view and cart events but don't have purchase events, so that we can notify these users at, let's say, an hour later. For instance, hey, Mr. User, did you forget to purchase the items in your shopping cart? Or were you interested in adding anything else? Or can we help with anything? And so on and so forth, right? So close to real time, we can analyze these events. And we're going to do that in the analysis bit in the Event Analyzer application. And we are going to use Spark Structured Streaming to analyze these events very quickly. So in this Event Analyzer, we're going to create a Spark session. So here under main, we're going to have a val Spark as Spark session.builder, and then let's say app name, abandoned cart analysis. And then I'm going to have master, and I'm going to use local 2, local 4, or local star because we're going to use structured streaming. So we need at least 2 threads for this application. And then I'm going to have get or create. Cool. I'm also going to say spark context set log level warn so that we don't get spammed with a lot of logs when we start this application. And I'm going to use the Pulsar Spark connector. So I'm going to have my events data frame as spark.readStream.format. And much like you can use Kafka, if you have the Pulsar connector for Spark, you can use format Pulsar. And of course, we need to pass in some additional options. So I'm going to have option with service.url. And I'm going to pass my service URL constant. So I'm going to import my constants. So constants everything. Service URL. And then I'm going to have option with the admin URL. So admin.url. And then need to pass the topic. So option with topic and the topic name. Now, optionally, you can also add some authentication tokens, and you can find the options in the blog post. So optionally, auth tokens. And then finally, I'm going to call load, of course. So this will be a streaming data frame. Now, this streaming data frame will contain some binary data, much like Kafka, so we need to parse our data here in Spark. So I'm going to have my parsed events data frame as events data frame, and then I'm going to use select expr, and I'm going to use cast value as string, and I'm going to use dot as string so that we can obtain a data set of strings. Now we need the implicit encoders, for which we need to import spark.implicits. So Spark implicits everything. And at this moment, we have a data set of string. So we will need to map everything and convert those to some data structures that we care about. And for our little use case, we care about these analysis events, which contains the user session, user ID, event time, and event type. So we need to parse them. So for every string, I'm going to parse my event, which is, and I need to decode the string explicitly using Circe. So I'm going to use decode of type event. Now, decode is a function from IO Circe parser, so I'm going to use import io source parser. So we need to decode event and then pass the string as argument. So I need to pass the type and the string that I want parsed. And this, if I remember correctly, this returns an either. I'm going to say get or else, and I'm going to use event.empty in the case that the event could not be parsed correctly. And then I'm going to turn this event into an analysis event. So analysis event using the event.user session as the unique identifier, event.user ID, user ID. Then I'm going to use the event timestamp. I think that's the third field, the event time, which is a timestamp object. So I'm going to use new timestamp from Java SQL with event.event time. And finally, I'm going to use event.event type, this view, cart, or purchase event types. Right, so at this point, we have a data set of analysis events, which we can now do Spark SQL on. So I'm going to have val, let's call this checkout events, as parsed events data frame. So I'm going to use df here, and I'm going to add Spark structured streaming specific features. For instance, I only care about events that are 30 minutes young. So I'm going to use a watermark here. I'm going to use the event time as the column, which is the field of this data. And I'm going to use 30 minutes. I don't care about older events than 30 minutes. I need to act now. Then I'm going to do a group by, and I'm going to group by the column. And in order to use the call function, I need to import something. So I'm going to import Spark org Apache Spark SQL functions, which includes call, group, and so on. So we have call, and I'm going to use the user session as the identifier. Then the column user ID, and a session window, which is a particular feature that was added in Spark 3.2. This is very, very powerful. So a session window for the column event time. And I'm going to use, let's say, 80 minutes. I've played with this data quite a lot, and I know what gives some really interesting results. So I'm going to use 80 minutes. And session windows are pretty interesting because if we receive another event within 80 minutes, then the session window will be extended, and Spark will naturally do that automatically. So I'm going to use an aggregation function. So I'm going to say ag with collect list. So I'm going to collect all the event types per user session, per user ID, per session of 80 minutes. So I'm going to use collect list of event type. And I'm going to call this as event types, plural. Then I'm going to filter those event types for which we have cart events. So I'm not really interested about users just browsing through my online store. If you remember, most of these events are simply view, and as I scroll through this file, most of these events are view. I only care about cart events. So I'm going to use array contains, and I'm going to pass my column event types, plural. And I care that this column contains an event of type cart. So I'm interested in the users that have cart events that have added products in their shopping cart but did not purchase something. So I'm going to use select, and then I'm going to use my fields here. So I'm going to use column, and my little session window is called session window. It didn't make sense to give this another name. So session window dot start as, and I'm going to use start here, call, we add a comma here, and paste this, and I'm going to use end. So session window dot end. Then I'm going to use column for the user ID and column for the user session. This is the session identifier, and the column with event types that we're going to see at the very end. So this is the data frame that we're analyzing in close to real time, and then I need to push this data frame somewhere. And I'm going to push it to the console, obviously, because I don't really have a production-ready infrastructure at my disposal right now. So I'm going to use checkout events data frame, then write stream. Then I'm going to use output mode complete. So output mode. That I'm going to use from spark.complete, and then I'm going to use an option for truncate to say false. Then I'm going to use format console. Then I'm going to use option with num rows, and I'm going to use 10, so 10 rows per batch, and then I'm going to say start, and then await termination. So this is my Spark application. So we're parsing all the values that we receive from Pulsar as a string. We're decoding analysis events, which contains just the 4 columns that we need. Then we do a bunch of aggregations based on user sessions, user IDs, and their session windows. And we only care about those events that contain shopping cart events, but did not contain purchase events that we're going to see in the console. So this checkout events data frame just filters those user sessions that only have cart events, but we're going to also see the difference between those users who actually make a purchase and the users that do not. Cool. Now we need to start an actual Pulsar Docker container. So I'm going to open a terminal window and I'm going to use docker run. And I have here an already written command, docker run -it, and then I'm going to have -p with these ports, 6650 and 8080. The 6650 is the Pulsar port and 8080 is for the admin port. Name Pulsar, and then the image is Apache Pulsar /Pulsar:280, and then the Pulsar, bin Pulsar is the executable that is going to be run inside this Docker container. So I'm going to run this, and this will spin up the Docker container for Apache Pulsar. And in the meantime, I'm going to start my Spark application. So this event analyzer is going to be started first, and I'm going to keep Spark waiting. And apparently I have a compiler error because this decode name can be found in 2 places. So I'm going to take io_circe parser dot as the prefix, remove this import, and I'm going to put it here. So io_circe parser decode so that the compiler isn't confused anymore. So let me run my Spark application to listen on the topic. So Spark will start right now, and it should listen on the topic that I called events. Let's see. All right, now I have a giant stack trace, but because the topic does not exist, so I will need to go to my little Docker container. So I'm going to say docker exec docker exec -it pulsar bash. So I'm going to navigate to the bin folder, and then I'm going to say /pulsar-admin topics create events, so that I create this new topic. It'll take a couple of seconds. So the events topic should now exist. Let me restart my Spark application, and in this case the Spark application should not fail anymore. My laptop is taking off. All right, so Spark didn't crash at this point. And it should print a first batch, or is it waiting? Right, so we have our first batch and it's waiting for Pulsar to push events. Now at this point, I'm ready to push my events through Pulsar with my event producer application. So let me uncollapse that and let me run my event producer. Hopefully I didn't mess anything up. All right, fingers crossed. Now I have an error here, and I think I've seen this before while I was preparing for this video, because there is a runtime class change error for schema info impl, and I already have a fix for that. So I'm going to go to the circe package under com esg samuel pulsar for a circe, and I'm going to navigate here. And I'm basically going to copy what the library code does. So I'm going to copy this implicit def. So copy that, get back to my application, and in Event Producer, I'm going to define my implicit def. I'm going to add all the imports, and instead of schema info impl, I'm going to use schema info. So this is invoking some Java code. Apparently there is some incompatibility between the Java class files. So I'm going to stop my Event Producer, and I'm going to try to run it again. Now, fingers crossed, hopefully this will work better. It didn't crash, and we have a bunch of message IDs. So Pulsar is pushing, and now Spark should analyze some events. So notice that we have event types cart and so on and so forth. Now, I think look at that. We have a giant batch because the Pulsar events were pushed very, very quickly. So we might want to throttle that down a little bit. So in the message ID futures, I'm going to do a thread sleep. Let's say thread sleep for 20 milliseconds or something like that. And in the Event Producer, I'm going to rerun my application. Hopefully we can get some new events here. Let's see Pulsar pushing some events. And Spark should start displaying some new batches. So look at that. We have a bunch of batches here under Spark structured streaming, and then we can, let me stop both of my applications. And here under the event analyzer in Apache Spark, then I can analyze which users had shopping cart events but did not have purchase events. Look at this particular user. This had a bunch of view events, a bunch of cart events, and then finally the completion of the shopping cart through a purchase. But apparently this first user had a bunch of view events, a bunch of cart events, but no purchase events. So we can filter those out, and we can notify these people either via some application, if we have a smartphone app in our giant online store, or via email, or we can offer them some support help by allocating one of our support people to help them, and so on and so forth. So notice how easy it is for us to analyze data in close to real time with Apache Pulsar and Spark structured streaming. Alright, so this was a demonstration of how you can use Pulsar and Spark to deliver some results very, very quickly. I hope you enjoyed this demonstration. If you like this video, go ahead and click the like button for me and subscribe to the Rock the JVM channel for more videos like this. Check me out on Twitter and LinkedIn as I post fresh updates on upcoming material, and check out the Rock the JVM website for hundreds of hours, literally, on Scala, functional programming, and data-related tools such as Apache Spark, and much more. Until next time, I'm Daniel, signing off.